Welcome back to the stirring conclusion 7.2. Proportions. Alright, so we just finished off our proportion hit list of tests. Random tests, independent tests, and then normal tests. And so we're going to see, actually we're going to start doing some math again. Alright, so here we go. First problem. Mr. Sheeby overheard some teachers saying that 80% of all students at Craig watch the 100. Quite a few people watch it. Wondering if this is true, Mr. Sheeby randomly chooses 150 students, okay, and finds that 100 students watch the 100. Oh, that's a coincidence. Wow. Alright, does it seem like the teachers were right? Well, at first guess, you're probably like, dude, 100 out of 150 students, right? That's like what? 2/3, which is like 66%. So you'd probably be like, no, that's not 80%. However, maybe I just asked the wrong people, right? Is it possible for me to have asked, 150 people and have hit that 0.66 mark, even if the true population was 80%? I'm not going to always hit 80% on a sample. I could hit above or below, right? So here's what we got to do. All right. Check to see if the tests are satisfied for this proportion. So, is it random? Did we do random? All right. Now, this is my favorite part. Mr. Sheeby randomly chooses. Yes. So here. All right. Check. It's stated random, right? I'm sorry, guys. Stated random. All right. Cool. Alright, now remember, it's got to be random for me to be kind of accurate, semi. Is it independent? Alright, independent. Remember, this is the one where my n has to be less than 10% of the population. Well, everybody knows Craig has 1,700 students. That is the total population. That's big N. Alright. So, if I asked 150 students, is that less than 10% of the population? Ding, right? 10% of the population would be 170 students. I'm under that, so check. Yes. You know what? I'm going to type this out. Give me a second. Alright, yes. Less than 10% of the population was surveyed, right? Okay, and then finally, the last one. Maybe I'm just going to copy this. Copy, paste. Copy, paste. Maybe not. Okay, is it normal? Alright, did I have 10 successes and 10 failures? Meaning, did I get 10 people who watched the 100? And I got 100 students who watched the 100. And did I get 10 people who didn't watch the 100? Well, if 100 people watched it, that means 50 people did not watch it. So I have 10 successes, 10 failures, passes the normal test. Sweet. 10, I'm going to do this really abbreviated, alright? 10 success. If you were doing this on an AP test, hopefully you would write it a little bit more in context. 10 success, 10 failures. Oh my goodness. Guys, I am writing with a mouse, and I just can't write anything right now. Fails. At least, right? So, I'm at it right in that beautiful spot. Under 10% of the population, but over 10 successes, 10 failures. Cool. Now, alright, let's do some math. Make a normal curve and see just how close the sample is from the population. Alright, well, so here we go. Alright, so I'm going to make a normal curve. Alright. Oh man, that's bad. But we're going to pretend that's normal. Alright, now the center should be at 80%, because that's what the teachers claimed, right? Okay, now I got a sample down here at well, remember my sample, my p hat, was at 66, right? 667, we'll say. All right, that's my p hat. So I got under average. Okay, what is each standard deviation though? Ooh, right? Let's figure out what each standard deviation is. So the standard deviation of all the samples I could get, how wide could I maybe move from 0.8, right? If this was true, if 0.8 is true, how far away could I go? All right. So remember, formula for this is P times 1 minus P all over my small n. Now, remember, when we're talking P, that is this guy. That's that guy. It is not what I got. Okay? It is not that. I'm assuming 0.8 is correct. And we'll get into that more in like chapter 9. Okay? But let's just see. Alright? So I'm going to go divided by, so this is going to be 0.8 times 0.2 divided by, I sampled 150, so I'm trying to see exactly how wide can this deviation go, or where are all my samples going to go. Divided by 150, and take the square root of that guy, and gosh upon. Alright, so my standard deviation for my curve, how much wiggle do I got if I sample 150? It's actually 0.032. 0.0327. Alright, that's my standard deviation. So that means at this point right here, that's one deviation away. That's like 0.8327. And one deviation below is going to be 0.7673. Right? Does that make sense? And so on and so forth, going down. Now remember, I got 0.66. How far down is that baby? Whoa, that's like way down there, right? That's not very likely, guys. That's not very likely. Alright, if I got a result down here, that would be really hard to get if this was true. I don't know if you guys are kind of understanding this or not, but basically saying if 0.8 is true, my result was way down there. Okay, so how close was my sample to the population? Not really close at all. I'm guessing those teachers, I'm really guessing those teachers were off on their estimate. I bet you anything, the actual estimate is closer towards mine. Okay, because it would be really hard for me to get this 0.66 as an answer. Right. Okay, that's kind of like what we're doing. Okay, next. Let's say Mr. Sheevy takes a simple random sample of 120 students at Craig who play a sport. Suppose the real population proportion is 35%. What's the chance his sample of 120 students falls within 2% of the real proportion? What? Okay. So first of all, let's just go through. It doesn't say to go through, but let's say, alright, did I meet my random? Oh, I did a simple random. Check. My random's good. Did I meet my independence test? Is it less than 10% of the populations? Okay, well the population at Craig, I've already stated, is 1,700. So 120 is less than 10%. Independence, check. And then normal, do I have 10 successes and 10 failures? Well, you'd have to figure out, alright, if what is the chance a sample of 120 students falls within 2%? Well, I guess I don't really know how many successes and failures I have on this. But here's basically what's going to happen. I'm going to draw a normal curve. As normal as I can do. The center should be at 0.35, because that's what it says. Alright? The real proportion is that. Now, I want to know within 2. So I want to know what's the chances I get within 0.33 and within 0.37. So what is the chances I get in there? So I'm trying to figure out this guy. And you might be like, oh shoot, this is a z-score problem, right? Okay, so remember, z-score, to find the area in between, I take my high minus my low. So I'm going to do a z-score. It's what I got. Well, what value do I have right now? I got 0.37 minus what I should get. I should get 35, right? That's the average. Divided by the standard deviation. It's not mentioned in here, right? Well, would you guys agree the standard deviation I could do? Now, which one of these do I use for standard deviation? Remember, it's p times 1 minus p. I always go off of the one that I know for sure is the actual amount. So I'm going to go 0.35 times 1 minus p, which is 0.65, divided by my sample number, and I did 120. So how spread out is this normal curve going to get? All right, and that would be my answer there. All right, I'm going to pause it, figure this all out. I'm probably also going to do the other one as well. All right, calculated z-score for you for both. This is the high, and my z-score is 0.46. So I could give you my p-value here. What's the probability of that event happening? And then obviously the z-score of 2 below, so I put in the 0.33 minus what I should have got divided by the same standard deviation, and I got obviously just the reverse, because I'm just, instead of 2 above, I'm going to be 2 below. And so let's find the p-value for that. So I've got my normal curve right here, and I'm looking for 0.46, I believe. Yeah, 0.46. I'm going to look at my high first. So 0.46 would be right, yeah. All right, 6772, 6772, 6772. All right, where are we at? All right, so it's 0.6772. All right, and the probability of the other one happening would be a negative 0.46, negative 0.46, which is right here, negative 0.4, and then 6 is right here. 0.3228, 0.3228, 0.3228, 0.3228. All right, 0.3228. All right, now I just take my high minus my low, and that will be the area in between. So I'm going to go 0.6772 minus 0.3228, and I get an area in between those two guys. The space in between is 0.3544. So what's the likelihood I fall within 2%? Well, I have about a 3544. All right. I have 35% chance that I'm going to fall within 2% of the actual amount if I sample 120 students. That's pretty good, guys. All right. I know this whole scene, this whole chapter is probably running a little loofy in your head. Okay? Take some time. Rewatch everything if you need to. Work on the homework. All right, I'm running out of time myself. I want you guys to work on, the homework is on the first page, sorry. For 7-2, I know I showed it to you guys before. 7-2, yeah, 27, 29, and 41. Those are the ones I want you to work through. See what you got. Minus what you got divided by standard deviation. Just kidding, that's the easy part. All right, hats off to you all. Practice. This section needs to be memorized, or you're not going to do well after this. Bye-bye.